All right, so in this video, we're going to just take an example of how to solve questions related to match pairs. So there is one here, just over here. Let's open that. Okay, it's taking a while. Okay, so this is a question, and we can read through it to be sure that it's match pair. So the first thing you want to do is to identify whether this is truly a match pair. By next class, subsequent class, we'll be doing two pairs, right? I mean, two pair of sample as well, like two data sets, like just like this one, but it will be called independent t-test. Okay, so by then we emphasize again how to spot the difference, but simply saying, I mean, simply stated here, whenever the question, whenever you're dealing with match pairs, you will see that in the question, right? There will be a sense that these two data are similar. They are mostly coming from the same individual, okay? So let's read through. Do college students enjoy playing sports just as much as watching sports? Okay. A researcher randomly selected 10 students and collected the following data from them. Okay. So from each student, so these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. So from each student, a pair of data was gotten. From the 10 students, 6 and 5 was gotten. From the first student, 9 and 5 was gotten, right? So this is a rating, and the rating was, let me see, they were asked to rate whether they enjoy playing or watching, rate both of them from 1 to 10. So each student rated playing or watching from 1 to 10, and this is the data you have. So this is a paired sample because the data on the row where you have play and the data on the row where you have watch they are pairs coming from just 10 individuals. Okay, not 20 persons, but 10 individuals. So this is a paired sample. So when you have data like this, then you're going to use it to address the question. And the question here is, do college students, and let me pick up red, I think that will be brighter. The question is, do college students enjoy playing sports just as much as they enjoy watching? That is the question, right? So pay attention to the way this question is structured. I could change it slightly, and if I say, do college students enjoy playing sports more than watching? Okay, that's one way another way to state the question. And I could also say, do college students enjoy playing sports less than watching sports? Okay, so from these statements, I am getting my hypothesis statement, right? Okay, so we're gonna go through down there. When we get to that point, we come back and emphasize these three different ways of writing this question. So let's look at the first question here. The first question says, for this study, we should use, if you drop down this arrow, you see a bunch of tests, like different types of tests. Okay, so this is a sample, so we are using a t-test, right? But not just t-test, but paired t-test, okay? Paired sample t-test or matched pair, or two dependent. So let me write all that here. So this is a paired t-test, or you can call it matched pair. T-test, or you can say two dependent sample. Let's write that very well. Two dependent sample t-test. Okay, so it could be any of these, depending on what the author chose to call it. So when you drop down this arrow, find out the one that is saying the same thing. Every other one will say something different. So it's either it's called a pair t-test or a matched pair t-test or two dependent sample t-test or two dependent test of the mean. population mean. It could be, but the word dependent, matched, or paired is giving you a sense that these data, pair of data, are dependent on each other, because the same person that rated play and watch, so they have a dependency, they are paired, they are matched, and one is dependent on the other. Like the same person, the chances that that person rates both high would be low, but you see cases like that here, right? So yeah, the emphasis is simply that they are dependent, or they are matched, or they are paired. So that would be the type of test. Of course, it is a t-test, but in addition to just being a t-test, because we have a matching and a pairing going on, it is properly called two dependent t-test, right? Or matched pair, or paired t-test. And the phrasing could be different from what I'm saying, but you get a sense that you're talking about two data sets, and you're talking about a t-test. So these two together is what tells you which option here. Okay, so let's go to the next. The next says, what is your alternative hypothesis? I mean, your null and alternative hypothesis. So earlier on today, we saw this, and I stated that the null is only written one way. There's only one way to write the null. Let me try to move this up. Okay, there's only one way to write the null, right? Is that mu d is equal to 0. The mean of the difference between the two data sets is equal to 0. Okay, that is your null hypothesis. And the alternative would depend on the phrasing or the wording of the question. So let's look at the wording here. The actual wording is the one in black, not the ones I have written in red. I will explain the red following. So let's focus on the one in black. The one in black says, do college students enjoy playing sport just as much as watching it? So this is just saying, I don't know if they enjoy it more. I don't know if they enjoy it less, but are they enjoying it equally? Is it the same way? So if your null hypothesis says that they are enjoying it equally, because that's what the null is saying. The null is saying that if you subtract the mean for play and the mean for watch, you're going to get 0, which means the two are equal. We've explained that in the previous videos. So if what I'm saying is not clear, just go to the previous video to look at that. So the null hypothesis is saying UD is equal to 0. So the alternative is that I don't know if it is greater or less, because the question did not suggest that. The question is just saying, is asking, do they enjoy it differently, or as much as they do, So over here, we should just have the UD is not equal to 0. So this is implying that they may enjoy it more, they may enjoy playing more than they enjoy watching on average, or they could enjoy watching more than they enjoy playing on average. We don't know. So that is what this hypothesis is saying. Say it could be either way, but I know it's not the same. I know that the values, how much they enjoy, how much they watch, are not the same. But I don't know if it is bigger or less. And you could get that sense from the question. If you look at the data set itself, you cannot really tell. Maybe if you do a quick calculation, you might be able to tell. But right now, let's assume that just eyeballing it generally, you can tell, okay? But if the question is framed as this, do college students enjoy playing sports more than watching sports? Then your alternative hypothesis would be written as UD greater than 0. Right? Okay. If the question is framed the other way, do college students enjoy playing sports less than watching it? Then my alternative hypothesis would be written this way, right? So less than watching it, more than watching it. The symbol, the greater than and less than symbol, just goes with the statements that you have, okay? And this is not the only way to state less than or greater than. You just need to read through and ask yourself, does the question imply less or more from the way it is stated? And then you write your alternative hypothesis that way. So you get a practice. I have just like 2 questions for homework in this session. You get to practice this in that, okay? So let's move on to the third one, the test statistics, which is really the key thing here. So the test statistics, this is a paired test statistics, right? It's a paired t-test. So you're comparing 2 pairs. First, let's take note of the formula. Okay, let me continue using red. So the t-test statistics is represented this way. You can use any symbol, it doesn't matter. So, but the test for, and let me use a D here. I think that will be better. for paired sample is the mean of the difference, okay, and the dash is put on top of D here, and so many other notation. You can find many other notation in the textbook, but just pay attention. Note that what you have here is the mean of the difference minus in the data, in the sample, minus the mean of the difference in the population value divided by the standard deviation of the difference all over the square root of n, right? Just the same as what we have, but now you're dealing with the difference. And so let's go to the data and actually put this in practice, see how we calculate this, okay? And I will pick up a new, just a plain page, Word document, to just write so that we'll have a clear writing. But we'll pick up the data first. So let me resize this and see if I can just copy the data up. Okay, a whole bunch, no problem. So let's see if, okay, let's look at that. See if I can crop this. Okay, so we just need to have the data. So let's crop up all of that. It's not activating. Okay. So if I reduce this, so we can just focus on the data. Reduce this also. Okay, so this is the data sets, and we're trying to compare the two, right? I'm going to put this on a vertical plane to make it easy. Anyway, I could just go ahead and pick them up that way and write them down on a vertical plane to make it easy for us. So let's say over here, this is the difference in my data, okay? The difference in my data. So, okay, so let me put serial number here instead. And so this is the difference in my data that I'm computing. So for the first student, that'll be 9 minus 5, right? So I'm using play as the first one, right? And this is important in the way you interpret the results. So pay attention to the way you do that. So essentially, I'm using this one as my mu2, and I'm using this one as my mu1. And my null hypothesis here, let's write it over here. My null hypothesis here is that mu2 is equal to mu1, right? Okay, and in a simplified form, we say this can also be written as mu2 minus mu1 is equal to 0. Okay, and then finally, for our notation here, we said mu d is equal to 0. This is the one you write. This is the summary, right? This is the simplified form. You could ignore all these ones, but I'm writing them for sake of clarity, for explanation. But this is the one that we use eventually, because this is representing everything we also have, okay? So if this is the case, so pay attention, take notes, because it will affect the way you interpret the question, the answer, the result. Take note that we are using play as our mu2, and we're trying to subtract mu1 from that, which is watch. Okay, so 9 minus 5 will give me, for the first student, will give me the difference of 4. Okay, 4 minus, for the second student, 4 minus 1 will give us 3. For the third student, 5 minus 3 will give us 2. For the fourth student, 4 minus 5 will give us -1. For the fifth student, 9 minus 8 will give us +1. For the sixth student, 6 minus 4 will give us +2. For the seventh student, 4 minus 3 will give us +1. Okay, let's move down a little bit here. Okay, and for the 8 students, so we just did, so let's number this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for the 8 students, 4 minus 4 will give us 0. For the 9th student, 5 minus 2 will give us 3. And for the 10th student, 6 minus 5 will give us 1. Okay, and let's go through this again, just the way we did in class today, right? You want to go through it over again, just to be sure, because there's no need rushing ahead. If you make mistake here, everything you're working wouldn't be correct. So just verify that this step is very correct. So for the first student, we have 9 minus 5, which is 4. For the second student, we have 4 minus 1, which is 3. For the third student, we have 5 minus 3, which is 2. For the fourth student, we had 4 minus 5, which is negative 1. And for the fifth student, we had 9 minus 8, which is positive 1. For the sixth student, we have 6 minus 4, which is 6 minus 4 for the sixth student, which is positive 2, right? Yeah, that is another. And then for the seventh student, 4 minus 3, which is positive 1. For the eighth student, 4 minus 4, which is 0. For the ninth student, 5 minus 3, 2, which is 3. And for the 10th student, 6 minus 5, which is 1. So our data is correct. Okay, so remember the formula you're trying to get. Why are we doing this? We are doing this because we are trying to calculate the test statistics. And what is the test statistics? Given by this formula here, right? And maybe I should write it out very well. So the test statistics for the PET sample is giving us the mean difference, the mean of the difference, minus the population mean difference divided by standard deviation of the difference all over square root of n, right? So essentially you need n, and we know what n is, the sample size, how many people were surveyed. If you look at your data point here, there are 10 of them, right? Each person having 2 data by watch and play. So we have 10 here. Okay, so we already got this taken care of. Now, I think we should do this at this time. Let's look at mu-d, right? Mu-d is the population mean, okay? If you pay attention to what we've been doing, you see that this is 0. That's what the null says. In fact, that's the null hypothesis. The null hypothesis says that the difference is 0, right? And I think maybe we had it better on this page. Let me scroll up here. Okay, I think we have it here, right? And maybe I should just write it all over again to make that clear. So the null hypothesis is saying that both the mean for play and watching is equal to 0. They are equal to each other, okay? If they are equal to each other, it means if you subtract them, you get 0, right? It means if you do mu2 minus mu1, you should get 0, okay? And then if you decide to represent that difference with a symbol, if you decide to represent this thing here with a symbol, mu-d, then your null hypothesis could be stated in a more simple form. Mu-d is, equal to 0, okay? So the difference in the mean is equal to 0. So let's go back to this other page to continue. So over here, the mu-d, the difference in the mean, is 0. Okay. So what you have left, or what you actually need remaining, is xd, the mean of the difference. Let me be consistent with my notation, but understand that this is notation, right? Everything you're seeing here, it is just notation. And put this down. Okay. Just a moment. Let's maximize this so that doesn't happen again. Put that down. Okay. So I'm trying to just clean up this so I could write with consistent notation I've been using. Okay. So pick up, right? What we have left, or what we're looking for to be able to calculate the test statistic for this PET sample, is the mean of the difference. Okay. Right, we don't know what it is. We're going to calculate from the data, and we're going to calculate standard deviation of the difference also from the data. So once we get these 2 items with the 2 we already have, we're able to calculate the test statistic. Just plug into this formula, right? Okay, so let's go back there and finish up that. So here, our interest is to use this data here. data set here that we found the difference, we are going to compute the mean from here, right? And it's, okay, so let me delete all this in a way that, okay, that is touching what I don't want, in a way that I can write there without, while you are seeing the entire data set, right? So let's see if we can select everything over here. Everything them elsewhere, so I think that is okay. Let's select this one, just this one, so long. Okay, trying to pick everything again. Let's do a manual selection of these items. Okay, this one. Okay, and this one really. Okay, not that way. This one. Okay, so let's go ahead. So we have this data set already here. We've just found, these are serial number, remember? This is serial number here, and maybe I should write it better. Not confuse anybody. Okay. This is serial number, right? What color is that? I think that was green. So this is serial number. Okay, that is what this is. So student 1, 2, 3, 4 to 10 students, and we subtracted the difference between their score, play, watch, and we got all this, right? So now what we're going to do is to sum them up. So we are looking for the mean of that difference, right? And by symbolically is denoted as, that doesn't look thick enough. Okay, symbolically is denoted as the mean of the difference. Okay, yeah, so we go ahead and find the difference in this, right? So if we're looking for this difference, the mean would be given as the sum of all those differences divided by how many they are. The same definition of mean that we know. So we're going to add up everything here, okay? So let's go ahead and use the calculator. Okay, let's move it over here on this side. So I'm simply going to add up the column of difference. So this is 4. I think the non-lock is not on. This is 4 plus 3 plus 2 plus, we can actually do this manually instead of doing that. Okay, no problem. Plus minus 1. Okay, so I see the way this is working. Let's start all over again. That's, so you put in the number before the sign, right? Okay, so let's see. So we have 4 plus 3 plus 2, right? Plus negative 1. So we say 1 and then put in the negative sign, right? Then plus positive 1 plus 2 plus 1 plus 0 plus 3 plus 1. Okay, so we got 16. And let me do a quick check manually, right? So 4 plus 3 is 7, plus 2 is 9, minus 1 will give you 8, plus 1 is 9, this is 11. This over here is 12, plus 3 is 15, plus 1 is 16. So 16 is okay. So coming back here, the sum of the difference is 16. And we know that we have 10 data points, so we are dividing by 10, and that gives us 1.6. Okay, so the mean of the difference is 1.6. Okay, all right. So just transferring that in annotation, let's write it here. So we are having that the mean of the difference is just 1.6. And I think my annotation might be confusing. So maybe here, let me pick up this and do this better. Maybe here, what we should have had, is the sum of just the difference, right? Just the sum of the difference. Okay, because the sum of the difference divided by n that we did, sum of this difference. divided by m. Okay, so that this should remain the mean of the difference. Okay, give me a moment. Let me unify the notation so that it doesn't get you confusing. But I'm hoping you're paying attention to the concepts, because that is what guides you. These notations are just representations. So let's just have some uniformity here. So the mean of the difference is defined as the sum of the difference divided by number of items, which is what we did. So the mean of difference is 1.6. Okay, I hope that helps. So what we need else before we do our statistics is the standard deviation of the difference. Okay, and we're going to try to do that here. So I think I can move this. Yeah, let's see if it's possible. Can move that. So let's bring this down here, which is actually where it should be. Okay, so our goal now is to calculate the standard deviation of the difference. That's what we're hoping to calculate right now. Okay, let me delete this entire. Okay, so I did that because I want to have it on this table too. Okay. So, and we know the formula for standard deviation. We know that I should place it down here. We know that the standard deviation is simply, we know that the standard deviation here will simply be the square root, right, of the sum of your data point. Your data point in this case is just those differences, right, minus the population mean, or the mean of the difference that we got from this sample. So let's make that clearer. Minus the mean of the difference that we got from this sample square divided by n minus 1. So it's just the same thing as we were doing before, just that your data is not the difference, right? So let's go back and finish up here. Okay, so over here, we'll go ahead and try to do the numerator, right? Let's try to get this numerator first, right? So here, we are looking at the difference minus the mean of the difference, right? And we're going to square it, okay? Already we know that the mean is 1.6. So we're going to pick each of these data minus 1.6, and then we square it, right? I have a calculator here that we could use. Just a moment. So here we have the data 4 minus the mean, which is 1.6. That gives me 2.4. I'll raise that to power of 2, and I get 5.76. So here I have, let me turn to black. I used to use black. So here I have 5.76. Okay, and the next one is 3. So I have 3 minus 1.6. That gives me 1.4. Raise that to the power of 2. I have 1.96. Okay, the next one is 2. I have 2 minus 1.6. That is 0.4. Raise that to the power of 2. I have 0.16. So here I have 0.16. The next one is -1. So be careful with your calculator how you do that. -1 minus 1.6. That gives me -2.6. That makes sense. Raise that to the power of 2. I have 6.76. The next one is 1. 1 minus 1.6 gives me -0.6. I raise that to the power of 2. I have 0.36. So this is 0.36. Okay, the next one is 2. I've done 2 before. We saw that 2 was 0.16, so we just use that. We've done 1 before. We saw that 1 was 0.36, so we just use that to save time. And let me move down a little bit. And then we go to 0. We've not done 0 before. Okay, so 0 minus 1.6 will give me -1.6. As expected, raise that to the power of 2. You have 2.56. The next one is 3. We've done 3 before. We pick up that value. That is 1.96. The next one is 1. We've also done 1 before. So we pick up the value there, which is 0.36. Okay, so this is what you have. Is the sum of this, and let me put it underneath that, right? Is the sum of all this, that is your numerator there, the sum of the difference minus the mean of the difference square. That is, if you add that column, that is what you get. That is your numerator. Okay, so let's go ahead and add that. And we do the addition twice just to be sure that we have the same value. So let me place this here. I'm going to add this column, right? So I think the calculator could work here. Clear everything. So we have 5.676, and we are adding 1.96. We are adding 0.16. We are adding 6.1, no, 6.7. Let's move back here. 6.76. And then we add 0.36. And we are adding 0.16, adding 0.36 again, 2.56, 1.96 plus 0.36, 20.4. We're going to do this again just to be sure we're not making a mistake, right? But if everything is okay, let me pick up the green color to be consistent. If what we have done is okay, we should be able to reproduce that, right? So, but let's assume it's okay for now and work here. So, plugging in here, solving this. Okay, let's do that. You see that the SD is equal to the square root of, if what we have done is okay, we got on the numerator 20.4. So we have 20.4 divided by n minus 1. N is 10 because there are 10 data points or 10 students, right? Subtract 1, that would be 9. Okay, so but let's confirm that numerator again just to be sure. So get into the habit of doing this. That is a useful habit to adopt. Okay, so let's do the addition again just to be sure that we have the right thing. And if the second one differs, then you do it a third time. Okay, just be patient with it. On the assessment, you're having just 3 numbers, so you don't have to work all of it. So let's go. We have 5.76 plus 1.96 plus 0.16 plus 6.76 plus 0.36 plus 0.16 plus 0.36 plus 2.56 plus 1.96 plus 0.36. That gives us 20.4, so that our first computation was okay, right? So let's go ahead and finish up the standard deviation. So when you do this, of course, the SD will be equal to the square root of, let's divide that, and we can actually do it from the calculator here. 20.4 divided by 9, that gives us 2.266666. So let's keep this at 4 digits. So we should have 2.6667. Okay, and we're taking the square root to get the final answer. So the square root of that, I think this can also do it. Just press the square root here. That gives us 1.5055. Okay, so here you have 1.5055. Okay, as your standard deviation of the difference. Okay, and let's write this very well so that it doesn't confuse you. So this is not just SD, but SD of the difference. So let's write it well. Okay, I don't want everything taken. Okay, careful. I'm trying to be precise with the notation so that it doesn't confuse you in any way. So bear with me. The technology, one functions from time to time. Okay, so if I do that, why is that selection not working here? Okay, let's try it again. Okay, that is better. So what I have here is better written as standard deviation of the difference. So this is a subscript, right? It's a subscript. Okay, so that value we found just now is equal to 1.5055. And earlier on, we found that the mean of the difference, again, trying to be precise with the notations. Okay, earlier on, we found that the mean of that difference is 1.6, right? So this is the two data points, the two estimates that we need to be able to finish up our work, right? So let's now go back to the data page, right? To the actual work. So over here, we're just going to plug in the values that we have. So computing our test statistics, our T stats, if I should use D here, is the mean of the difference, which we found to be 1.6 minus the population mean we found to be 0, divided, it's always 0, right? In this case, divided by standard deviation of the difference. I think we found 1.5055, right? So excuse me, 1.5055, and then you are dividing this, of course, with the square root of n, which is 10. Okay, so let's work this out. If we compute that, the numerator, of course, will be 1.6. So you're going to divide that by square root of 10 divided by 1.55. So you work that out slowly with the calculator. So take the square root of 10 as well. I'm doing it here. Square root of 10, I have this value. Okay, so that's 3.162277766. So I'm going to divide 1.5055 divided by the square root of 10. Right? That gives me 0.4761. Right? So when I simplify that too, then finally my T test will be 1.6 divided by 0.4761. That gives me 3.3606. So that gives me this, right? And if you round off, that gives you the value you have. Okay. All right, so just be diligent, work this slowly, and you're able to match that. The next thing is the p-value. Right? Question C is the p-value. And you know how we got that. It's the same thing as we did before. Okay, and I'm going to remain with the two tail that I used in class. The other issue that came up, I'm going to try to resolve that later, but I don't want to do that with this video. Okay, so here, take note that we are actually doing two tail, right? Take note that we are doing two tail. So you have this, right, as two tail. Okay, so here you have this is equal to, let me make this bigger. Try to enlarge it more. It's not getting big. Okay, so this is equal to, I hope you can see this, t.dist. Right? So I'm going to use two tail, the second option here. Double click on that. I have two tail. Then you enter the test statistics. Here we have 3 points. Let's be sure what the value is. Our test statistics here is 3.361. Or we can use the whole stuff, the one we got, so we can be more precise. So we got 3.3606. That is more precise than 3.361. That is already approximated. So let's use 3.3606. So you have 3. Let's start that all over again. Let me do that from the beginning so it will be clear to you. Is equal to t.dist. And I'm using two tail. So go ahead and have 3.3606 comma, the degree of freedom, we have 10. So you're subtracting 1 from that and you're getting 9 here. Close your parenthesis and press enter, right? So let me write this down very well. You know that what you're doing here is to put in the formula T dot dist, okay, dot two-tail, because we are doing two-tail test in this instance, parenthesis open, your test statistic, and your degree of freedom. And you know degree of freedom is n minus 1. Okay, so this is what we put in here, and that is how we got this to be our p-value. So the p-value that came out when we did that, like you can see that is 0.008381. Okay, so that is what came out. Let's see how close it is to this one. So we got 0.008381. So we had 0.008381. Okay, so if you run that off, of course, you match exactly the same thing. Okay, so that is your p-value. And then the next is just the same as we did in one sample test, one sample data, one population. So everything follows the same way. So let's look at the p-value here. I mean, let's make our decision here on question B. Okay, so let's compare the p-value with alpha. And by the way, what is the alpha for this question? Alpha is giving us 0.05. Alpha is 0.05, right? So let's go back and compare our p-value. So obviously our p-value is smaller, isn't it? So we see that the p-value is actually less than alpha. Okay, so whenever p-value is less than alpha, what do? We reject, right? So we reject. So here the answer will be reject the null hypothesis. Okay, we reject the null hypothesis. Okay, so when you reject the null hypothesis, what is your conclusion? What does that mean? Okay, what does this mean? So remember the null hypothesis that you are rejecting. The null hypothesis is that mu d, the difference between them, is equal to 0. So when you reject the null hypothesis, you're saying the difference is not equal to 0. Okay, so it means you're supporting the alternative. Your alternative is saying it is actually different from 0. It's not the same as 0. So let's read these options and see the one that agrees with that. Okay, so first of all, remember that whenever you reject the null hypothesis, it means your outcome is statistically significant. So let's read the first one. The first one said the results are statistically significant. That is true because we rejected. If we did not reject, then it's not statistically significant. So because we rejected, this is true. The result is statistically significant. So let's read on. The results are statistically significant at alpha 0.05. So there is sufficient evidence to conclude that the 10 students that were surveyed rated playing sports the same as watching sports. So this is the problem. So let's see. H1 for this research is that the difference is not equal to 0. And what is the difference you're comparing? You're comparing playing sports versus watching sports. And you're saying they are not the same. They are not equal. They are different. Okay. So let's read this again. It says the results are statistically significant at alpha of this, which is true. So therefore, there is sufficient evidence. Since we rejected this, right? You are supporting this. Take note of that. Okay. So the results are statistically significant at alpha 0.05. So there is sufficient evidence to conclude that the 10 students that were surveyed rated playing sports the same as watching sports. But that is not true, right? The same is what the null says. The null says they are the same. Because if they are the same, then if you subtract playing sports, the mean of playing sports from the mean of watching sports, then you're going to get 0, right? That's what the null is saying. The null is saying the difference between them is 0. But we know it's not because we rejected that null. We are supporting the alternative, which said they are not the same. So that makes this answer wrong. Okay, the first part was correct, but the second part was wrong. Let's look at the second one. It says the results are statistically insignificant. That stops us there. That makes it wrong. Because we rejected out the null, it means the result is significant. So from this point, we can stop here. This is wrong also. We go to the next one. The result are statistically significant at alpha 0.01. That is true. So there is sufficient evidence to conclude that the population mean rating for playing sports is not the same as the population mean rating for watching sports. And that is what our alternative is saying. And remember, we supported the alternative. We rejected the null and supported the alternative. So that is what exactly the alternative is saying. But let's read the next question to be short, because sometimes there could be an item that is tricky there. So let's look at the next one. So the next one says, the last one says, the result are statistically insignificant. So that makes it wrong. The result is significant. So this is wrong, this is wrong, this is wrong, and this is the correct answer. Okay. All right. So I hope this helps. With these two videos in these two sections, you should be able to do complete homework 9.1, but it's not due until after class next week. Okay, but I mean, if you can walk through it, that will be perfect. Yeah, so that by next class, when we're trying to review this again and do something in addition, you will be comfortable. Okay, so I hope you watch this at the very worst during our class. I hope that is the time you're watching it, or you could do that after, but try to do it at least with the time space that is meant for this class, and then try to attempt the homework 9.1 already posted. All right, I will see you on my return. Keep up the good work and have a good one.